Hi everyone and welcome back. We've seen so far a couple of techniques that our sample used to inject into other processes. In particular, an interesting non-standard implementation of process hallowing. In this video, we'll look at this from the other side and see how we detect this. An interesting tool I found is PE-Sieve, which can detect process injection techniques like process hallowing and others. It can spot shellcode injected into executable memory blocks of other applications, IAT hooks, and many others. Let's start with the script that uses call window procw and the bootstrapping shellcode to inject a dummy binary inside calculator.exe. To test the tool, we need a running process. So let's replace again the beginning of the shellcode with an infinite loop. So we have here EBFE. I've already replaced that. This is the infinite loop. If you remember from the previous episode, the previous bytes were 60E8. Launch the script by pressing F5 or from the menu. It should be running in an infinite loop, giving us the chance to attach to the process. OK. I'll use again x32dbg. Let's see the process in Process Explorer. So this is the one in an infinite loop, PID 1076, which is, let's see, 1076 in hex 434. Close these windows and let's get back to the debugger. We will attach to this one with x32dbg. It takes a bit of time to load because the infinite loop uses all the memory. This is the process, PID 434. The thread is running. If we pause the execution, we should land on the infinite loop. Let's replace the first two bytes with their initial values. If you remember, 60E8. We have this call instruction that goes into the first function. If we scroll through the code, remember this is the place where the process is created. Let's add a breakpoint. You see, create process in suspend mode. We're basically trying to find a place and break before the process is resumed. So for example, let's add a breakpoint on this instruction, call EAX over here. OK, this is not the one we're looking for. Let's see the next one, the next call. OK, this is write process memory. Most probably this is the place where memory is injected. We're not interested in this either. Let's try here. Get thread context. We're getting close to the end of the shellcode. Write process memory again. Set thread context, and following this, we should have the resume thread function as you see here. Before resuming the thread, let's use the PE-Sieve tool. we will use an administrator command prompt because the tool works better with debug privileges. We will use the default options, specify the PID, which will scan for multiple injection types. PID. In this case, the suspicious process is the calculator, which has the PID 1720. 1720. As expected, we have a few suspicious results here. For example, it detects that the process was implanted. It detected an implanted PE. The implanted PE is actually the Hello World application that we injected using the process hallowing technique. If we look at what has been scanned, PEsieve checked the calculator.exe process, the 32-bit version. It also created a dump file with the extracted memory blocks from the injected process. Let's allow this program to end. If you remember from the past videos, we should have a text file created which signals that the injection was successful. The author of PEsieve has another related tool that is able to scan the full system for injected processes. There is a DLL library as well. I encourage you to check the project because it's really useful, and the author has a lot of other interesting tools. Thank you very much, and make sure to test this on your own environment. Looking forward to your comments. Thank you and take care.